Very good morning, students. Hope you all are safe at home. In last video, I have introduced the topic radioactivity, students. Now, today, in this video, I will explain you isotopes. What are isotopes, class? The atoms of the same element. The atoms of the same element which are having the same atomic number. That means they have the same number of protons. Atomic numbers refers to the number of protons, because in the last video I have explained you. Okay, so the atoms of the same element which have the same atomic number but different mass number. That means the number of neutrons are different in these atoms of the same element. Same atomic number but different mass number are called isotopes. What does it mean? From this definition we can conclude that they have same protons. If they have same protons, they have same electrons as well. But they have different mass number. If different mass number means what? Protons are same. That means neutrons are only different in these isotopes. That means in isotopes, same protons, same electrons, but there are different number of neutrons in isotopes. Now, since in these isotopes they have same number of electrons, that's why they have their chemical properties are also same. Why the chemical properties are same? Because chemical properties depends on the number of electrons. Since same number of electrons are there in the isotopes, then their chemical properties are also same. But their what is different? Nuclear properties are different because they have different number of neutrons in their nucleus. Okay. Now, what do you think about the place of these isotopes in the periodic table, class, students? Now, since place in the periodic table depends on the number of protons. I told you atomic number depends. Atomic number decides at what place that element will be placed in the periodic table. So, since they have the same atomic number, so all the isotopes of the same element have the same place in the periodic table. Their places are not different. Now, I will give you, students, few examples of isotopes. Okay. The first example of isotope is hydrogen. Hydrogen has three isotopes which are 11H, 21H and 31H. The name of 11H isotope is protium. The name of isotope 21H is deuterium and third isotope 31H is tritium. Now, since we represent an element by this way, A, Z, X, where X is the symbol of that element. A is the mass number, Z is the atomic number. Same way here. One is the mass number and one is the atomic number. Atomic number is what? The number of protons in a nucleus. That means proton is 1. And what is mass number? Mass number is the sum of protons and neutrons. If there is one proton and its mass number is also 1, that means what? That in the nucleus there is only one proton. There is no neutron. So in protium isotope there is one proton and neutron is 0. Now in deuterium, if we talk about deuterium has one proton, but in the mass number it has 2. That means one is proton and another will be neutron. So the number of neutron is also 1 in this case. Third isotope is tritium, class, students. Tritium. 1 is the atomic number. That means what is the proton number? 1. And mass number is the sum of proton and neutron. If proton is 1, that means how many neutrons are there in the nucleus? Number of neutrons are 2 here. Now, second example, carbon. Carbon has 3 isotopes, 12,6C, 13,6C, 14,6C. In this, protons are 6 and neutrons are also 6 because the mass number is the sum of proton and neutron. If out of 12 there are 6 protons, then how many neutrons are remaining in the nucleus? 6. Now, we will calculate from here 13,6C. Protons are 6. Out of 13, if 6 protons are there, that means how many neutrons are there? 7 neutrons are there. 14,6C, 6 protons and 8 neutrons. Third example, chlorine. Chlorine has 2 isotopes, 3517Cl, 3717Cl. Cl is the symbol of chlorine, class. In chlorine, first isotope of chlorine, 17 protons are there. That means out of 35, if 17 protons are there, that means how many neutrons? 35 minus 17, 18 neutrons are there. Likewise, in 17Cl, if 17 14 protons are there, then how many neutrons are there in the nucleus? 37 minus 17, that means 20 neutrons reside inside the nucleus, students. Now students, few points to be noted down are, first point is tin, whose symbol is Sn, has the largest number of isotopes. How many isotopes it has? 10 isotopes. It may be asked in the exam that which element has the maximum number of isotopes and how many isotopes. So tin has the maximum number of isotopes. Now isotopes are also of two types, stable isotopes and unstable isotopes. Stable which means they do not react easily, which do not comes into action very fast, whereas unstable means which show radioactivity phenomena very fast, very soon. What are stable isotopes now? Stable isotopes are those isotopes in which number of protons is nearly equals to number of neutrons. Number of protons is nearly equals to the number of neutrons class. Whereas unstable isotopes are those isotopes where number of neutrons is much more or much higher than the number of protons. Okay, the isotopes which we have studied like 11H, 21H, 31H. Here you can see the number of protons and the number of neutrons is nearly equal to the number of protons and neutrons. Whereas I will give you example of unstable isotopes. See, first example 23892U. U is the symbol of uranium. Uranium is a radioactive element. It shows radioactivity phenomena. I will tell you why it is showing, only why these few elements are showing radioactivity phenomena, because they are having unstable isotopes. Their number of protons and the number of different neutrons is, there is lot of difference between protons and the number of neutrons. For example, this 23892U, here number of protons is 92 and the number of neutrons is 238 minus 92, 146. Now you can see there is a large difference between the number of protons and number of neutrons. Whenever there is in the nucleus, inside the nucleus there is a difference between, large difference between protons and the number of neutrons, it becomes radioactive, it becomes unstable. Okay, it is ready to emit rays, radioactive rays. Second isotope of uranium is 23592U. In this isotope also see proton number is 92 and the number of neutron is 143. Again there is a large difference between these two. So again this has become unstable isotope, students. Okay, now the next topic is isobars, students. What are isobars? Now isotopes are the atoms of same element, whereas now isobars are atoms of different elements. Atoms of different elements having same mass number but different atomic number. Having same mass number but different atomic number. Again I am repeating, atoms of different elements I am talking about. In isotopes we are having atoms of same element. Whereas here atoms of different elements having same mass number but different atomic number. Different atomic number represents means they have different proton number. If different proton number, they have different electron number as well. Now same mass number, that means the sum of proton and neutron is same. Only the sum has become same, but the number of protons and the number of neutrons are different in isobars. For example, see here, first example of isobars, 2311Na. Na is the symbol of sodium, 2311Na and 2312Mg. Mg is the symbol of magnesium. You can see here that the mass number is same in both, 23. But the proton number in sodium is 11 and proton number in magnesium is 12. When you will find out the number of neutrons, it is also different. See, proton number is 11 here and the number of neutrons are 12. Whereas in 2312Mg, proton is 12 and the number of neutrons are 11. So when the mass number is same but different atomic number of different elements, they are called isobars. What they are called? Isobars. Now students, mirror isobars. What are mirror isobars? Just now I explained you isobars. Isobars are what? They have neither same atomic number, proton number nor neutron number is same. Here, when the number, what are mirror isobars then? When the number of neutrons and the number of protons get interchanged in the nucleus, like 2311Na and 2312Mg. Here, number of protons is 11 and number of neutrons is what? 12. Here, number of protons are 12 and number of neutrons are 11. See, is there interchanging? Here proton 11, here neutron 11. Here neutrons are 12, here protons are 12. So there's an interchange between number of neutrons and protons in both the different elements. So they are called mirror isobars. Whenever there is a number of neutrons and number of protons get interchanged, they are called mirror isobars. Now the topic is isotones. What are isotones, class? Atoms having different Z. Different Z means different atomic number but same A minus Z. That means number of protons will be different but the number of neutrons will be same. When the number of neutrons are same, they are called isotones. They are called what? Isotones. For example, see 2311 Na and 2412 Mg. Now you will be like confused that here it is 2312 Mg and here it is 2412 Mg. These are both the isotopes of magnesium. Okay. 2311 Na and 2412 Mg. Here you can see proton number is 11 and the number of neutrons are 12. Whereas here you can see proton number is 12 and the number of neutrons are 12. See, protons are different, number of protons are different but number of neutrons are same. So this is one of the example of isotones, students.